Hello everyone. In this video, we continue our journey in R programming language. Last time, we have installed R and RStudio. We also learned how to install packages. You can watch that video on the link above. Today, we will focus on variables, data types, and data structures, mainly the basics. In any programming language, you need to learn these first. To code well, you need to use them wisely. After watching this video, you will be able to answer these questions. First, what is variable, how is it defined, and what are the important points? Second, what are data types in R? And third, what are the data structures in R? Let us start with defining what variables are. Variables are basically reserved memory locations in order to store information. When they are created, they use some space in your memory. Each variable has a name, and names can consist of letters, numbers, dots, and underlines. Note that they cannot start with dots or underlines. As you may guess, each variable has a value. Let's see how they can be created. First, you need to write the name of the variable, then you assign a value for the variable. For example, var equal to 5. This creates a variable named var and it has a value of 5. And second, var2 is created and a character variable is assigned as its value. Lastly, a vector var.3 is created with values 4 and 5. As seen examples, there are three different types. They are created as numeric, a character, and a vector, which is a data structure. We first started with defining variables. We can move on data types. There are many data types in R. We begin with character. This object stores collection of characters. They are similar to strings in many other languages. You need to start and finish with quotes for defining them. Note that it can also be double quotes. Next, we have numeric type. Integers and floating numbers can be given as an example of this type. As you see on the screen, we can use class function to see which class it belongs. Integer is also one type in R, and it stores large integer numbers within a greater space. We need to use L to tell R to store this as an integer. Like in other languages, we have a logical variable type. This is a variable that can only take two values, true or false. While defining them, you need to write true or false in capital letters. Our last data type is a complex variable. You may remember complex numbers from mathematics. Each complex number has two components, real and imaginary. To define them properly, we need to include both components. Note that the imaginary part should be written with I, as you see on the screen. These are the basic data types used in our programming language. Misuse of them would cause lots of bugs, so be careful while defining your variables. Let us move to the data structures. We will show 6 different data structures, which are vectors, lists, matrices, arrays, factors, and data frames. Vectors are the very basic data structures in R. You can create an empty vector using the function vector with two inputs. The first input stands for the type and the second for the length. A call for the function without inputs results in an empty vector, which is a logical vector. As an example, we define a numeric vector with length 3. As you see, the initial values are set to 0. Alternatively, we can use the function C, which stands for combine. When using C, we need to write down each element of the vector. As you see, the type of the vector is character. We can also create vectors depending on the type. For instance, we can use character with an input 3. This results a character vector with length 3. We can extend this usage for numeric and logical vectors as well. Our next data structure is list. Lists are objects that can contain many different data structures and types. We can use list function to create a list. It can consist of different data structures. As in the example, ours consists of 2 vectors, 1 numeric and 1 character data type. Matrices are commonly used structures in R. They are 2-dimensional R objects. Function matrix can be used for defining matrices. The function gets 3 inputs, nrow, ncol, and byrow. Let us create our first empty matrix. We write only the number of columns and rows in order to create it. As you see, our first matrix is 3 by 3, and each element in it is NA. To create the matrix with values, we can use the function C. The matrix M is a 2 by 3 matrix with numbers from 1 to 6. If by row is true, R starts with filling the matrix from rows. Otherwise, columns are filled first. Lastly, the matrices can be constructed by combining either rows or columns. These can be done by using rbind and cbind function respectively. Arrays are our next data structures. They are the generalized versions of the matrices. They can be in any dimensions. The function array is used for defining arrays. Let us create a 3-dimensional array. As in the function matrix, we can use C function. When you print the array, you will see each third dimension. Towards the end, we have 2 more data structures. Factors are the data structures that are mainly used in statistical analysis. Actually, they are a type of vectors. The function factor is used for defining them. Our first factor is defined as the following. When you print it, it prints all the elements with levels. Basically, levels are the unique elements in the vector. You can use nLevels function to see the number of levels in a factor structure. And our last data structure is a data frame. Data frames are very popular and are used for storing data tables. Each column can be different data type. We can use data.frame function for defining a data frame. Data frame have lots of features and we will show them in another video. For now, we will only show how they are created. Let us create a primitive data frame with 2 columns and 3 rows. The first column consists of colors and the second column consists of numbers. When we print the data frame, it shows us all the data frame with its column names. We have discussed variables, data types, and data structures in our programming language. The use of these are very critical as misuse of them would cause nights of debugging. Thank you for watching, and if you have questions, let us know by writing a comment below. We will be happy to help you. If you like the video, please give us a thumbs up and see you in the next video. Bye bye.